Hello everyone, this is Dr. Sharif, and within this video we'll be learning how to get the reactions in this frame. The frame here is A, B, C, D. The support at A is a pin support. So here we have a pin support at A. Therefore, we have two reactions at A. We can assume this is Y at A. And then we have also an X at A. We have a fixed support at D. This is a fixed support. So at fixed support, as you all know, we have three reactions. This will be Y at D. Then we have an X at D. And there is also a moment at D. In this beam or in this frame, we have an intermediate hinge here. We have an intermediate hinge at this point. And as you know, at intermediate hinge, the moment we can take it from bottom side or from the right side, and in both cases, the moment equal to 0. The same also we can do for the second hinge. We have only two unknowns, X and Y, and there is no moment. So you can take a moment for this side and say it equal to 0, or you take a moment for this side and say it's equal to 0. This will help us to solve this problem. So before starting solving this problem, let's think first what is the easiest equation we start with. If we set summation of force in Y equal to 0, you will have two unknowns, YD and YA. So it will not give you a direct answer. If we set summation of force in X direction equal to 0, you have an XA and XD as well. So it will not give you an answer. Then how about taking a moment at B for this part, BA? If we take a moment at B here, we would be able to eliminate the YA, and the only unknown will be X at A. So we can find the X at A, and then we can move forward. So let's start by this first equation for taking a moment at B, but for the part BA equal to 0. Therefore, there is no loads at all here. So if you take a moment here from the point, the bottom, XA times 6 equal to 0. Therefore, XA equal to 0. In this case, there is no force at X at A, so this will be XA equal to 0, and let's write it also. This is a 0 value, and we know that the XA equal to 0. Once we have the XA, so it will be easy now to get the X at D by taking summation of force in the X direction. But before doing that, let's get the resultant of the force that we have it here. So the resultant here equals 1.5 times 6 equals 9 kilonewton, and it will be at the mid height, which is 3 meters here and 3 meters in this side. So now we can take summation of Fx equal to 0. Therefore, XA, which is 0, minus 9 plus XD equal to 0, and therefore XD equals 9 kilonewton going to the right direction, and this will be the second force that we found, the second reaction. This is the XD equals 9 kilonewton. This will be the second one. Now we still have the YA, YD, and M at D. For YA, we can take a moment here at C for that part. We have XA equal to 0. The only unknown, it will be YA, and in this case we can find it. Okay, so let's do that, taking a moment at C for the left part. Therefore, summation of M at C for left part equals to 0, and then let's take a moment. Clockwise rotation is positive, and positive or negative here, it's as you used to do, so don't worry about positive or negative. Just follow something and use it. Okay, so if you want to use clockwise rotation as positive, it's okay. If you want counterclockwise rotation as positive, it's okay. Just to be consistent, let's also use similar to what we did as the first one, summation of moment at C. Let's assume counterclockwise is positive, but here for the left side equals to 0, and therefore how many forces we have it here? If we take a moment here, this force will be eliminated because it's at the same point. Then we have 8 times 2. This is counterclockwise, it is positive, plus 8 times 4, plus 6 times 6, minus y times 6 equal to 0, and the xa is already 0, so it is eliminated. So we have 1, 2, 3, 4, and this is 0. Let's do that. Therefore, 8 times 2 plus 8 times 4 plus 6 times 6 minus y at A times 6 all equals to 0. And from here we can get the y at A. Let's do that and use the calculator. So it will be 8 times 2 plus 8 times 4 plus 6 times 6 equal all divided by 6. So the y at A equals 14 kilonewton going upward as we assumed. And this will be our third unknown, which is y at A. This is 14 kilonewton. Okay, so we found x at A is 0, y at D is 9, x at D is 9, y at A is 14. We need now to find the y at D, and it is easy now. We can get summation of force in y direction. Let's do that. So sigma Fy equals to 0. Therefore, Ya, which is 14 going up, minus all of these forces, 6, 8, 8, and 8, and 6. So minus 6, minus 8, minus 8, minus 6, plus Yd, all equals to 0. Okay. So the only unknown here, it will be the Yd. Let's get Yd equals how much? Okay, so 14 or 6 plus 8 plus 8 plus 6 minus 14. The Ya in this case equals to 4, or Yd equals to 14 kilonewton. And it is positive. It means as we assumed it as going upward in our calculations here, or our assumption. So it is as we assumed. Now we found this one. It is again 14 kilonewton, similar to the Ya. So Ya and Yd are the same, and the value 14 and 14. But of course, don't forget to make a check at the end. But we still have to find the last unknown, which is the moment at D. For the moment at D, the easiest way is to take a moment at C for this part. So we take a moment at C for the bottom side. We have already the X and we have the Y. We can get the M at D. Let's do this. So taking moment summation of M at C for the bottom part equals to 0, and therefore taking a moment here, so minus 9 times 3, this is 9 times 3, this is clockwise, so it is opposite to what we assumed here, so it is minus 9 times 3 plus 9, which is the xd times 6, plus 9 times 6 minus md equal to 0, and therefore we can get m at d equals how much? Let's calculate this. So it will be 9 times 6 minus 9 times 3 equals 27, and it is similar to what we assumed because it is a positive value, so 27 kilonewton meter, and the same directions that we assumed from the beginning at this point. Okay, so this is the moment at D. We got all the unknowns so far. So the last thing to do is to check our answer, and we can make a check by taking a moment at any other locations that we never used before. So summation of moment at A, and we have to calculate this. So taking a moment at A, we never took it before, so it will be minus 8 times 2, which is this value, times 2, again minus 8 times 4, minus 6 times 6, plus 9 times 3, minus md plus yd times 6, many forces, and let's check if it would be 0 or not. So we finished 8 times 2, now it will be minus 8 times 4, minus 6 times 6, plus 9 times 3, minus md, which is 27, minus yd, which is 14 times 6, and let's check how much it would be this value. So minus 8 times 2, minus 8 times 4, minus 6 times 6, plus 9 times 3, minus 27, minus 14 times 6. No, it is not 0, so there is something wrong with it. Let's check again. So this one, it was 8 times 2 clockwise, it is negative, negative, negative. This 9 is positive, md is negative. Yes, yd times 4, it would be like counterclockwise, so this value, it would be positive instead of negative here. Okay, so now let's check again. Minus 8 times 2, minus 8 times 4, minus 6 times 6, plus 9 times 3, minus 27, plus 14 times 6, and the resultant is 0. By getting this is 0, you ensure that all the values that you have here are correct. So this is 27 kilonewton meter, y is 14, y at A is 14, x at A is 0, and x at D is 9. This concludes our video, and thank you for watching.